Okay, let's finish 4.2a notes. The next subject is limit as n approaches infinity. So we want to think back about how we find horizontal asymptotes, because that is going to be the same method that we're going to apply here. So think about how we did that before. We compare degrees between numerator and denominator, and depending on which one has a higher degree or equal, then that's going to dictate what we do. So let's look at example 5. So if s of n is equal to 1 over n squared times n plus 1 over 2, then find the limit of s of n as n approaches infinity. So first we clean this up, distribute the n through, and we're going to get n squared plus n all over 2n squared, and we're going to find the limit as n approaches infinity. So we compare the degrees. Numerator and denominator have the same degree. Both have squared. So if they have the same degree, then we simply, just like how we find horizontal asymptotes, we just look at, we take the leading coefficients of those two values, of those two terms. So we get 1 over 2, so that's simply going to be our limit. Okay. Take the coefficient of degrees if degrees are the same in numerator and denominator. Okay. Example 6, find the limit as n approaches infinity for the sum from 1 to n for a quantity 2i over n times 2 over n. So first step, let's try to clean this up first. Multiply and combine, so we get 4i over n squared. Okay. And we were going to see if we can apply the rules that we have from our summation formulas. But first we want to try to isolate the portion that we want to replace, isolate the portion that we want to substitute. 4 over n squared, we can treat these like constants. So think of n as a constant. We can pull the n out, and we can also pull the 4 out. So we're going to be left with 4 over n squared, the sum from 1 to n for our quantity I. So this can be replaced with the second rule, which is n times n plus 1 all over 2. Okay. And we're not going to replace n values with a constant, because our upper bound remains as an n. So we're just simply going to simplify and then apply the rule that we have for by comparing the degrees. So multiply this through, n squared plus n times 4, so we get 4n squared plus 4n all over 2n squared. And now simply we can compare the degrees. They have the same degrees. So as limit as n approaches infinity is simply going to be our coefficients 4 over 2, which is equal to 2. Okay, our final example here. Find the limit as n approaches infinity for the quantity from 1 to n, from 1 to n for a quantity that's given here. So we need to do some work, algebraic work, to try to combine this into separate terms by getting rid of parentheses. So we have to FOIL this out and then distribute through the 2 over n. So first, 1 plus 2i over n times 1 plus 2i over n. If I FOIL this out, I'm going to get 1 plus 4i over n plus 4i squared over n squared times 2 over n. Distribute the 2 over n through. So I'm left with 3 terms. And now I'm going to try to split this up into 3 separate summations so that I can apply, I think of these as smaller separate problems, and then apply the appropriate rules for each. All right, so first 2 over n, I can pull this out and think of it as this summation from 1 to n for 1. We have a rule for a sigma of 1. We also have a rule for 8 for the sum of 1 over n of quantity I. We can pull 8 over n squared out. And finally, the 8 over n cubed can be pulled out, leaving us with summation from 1 to n for quantity I squared. We have a rule for each of these. We can replace the first with n, replace the second with n times n plus 1 over 2, and finally replace the third formula using the formula n times n plus 1 times 2n plus 1 all over 6. And simply using the rule that we covered from the previous page. Okay, so now let's simplify. So 2n over n, n squared plus n, but the n's cancel out, so I'm just left with n plus 1 over 2 times 8 over n. I canceled out one of the n's here already, so I'm left with, and I fold this out, so I'm left with 2n squared plus 3n plus 1 all over 6 times 8 over n squared. Okay, continue to simplify. 2n over n, 8n plus 1 over n, 16n squared plus 24n plus 8 all over 6n squared. Okay, and I can just treat these as separate terms. I can find the limit of each separately. So here the n's cancel out, leaving us with just 2 over 1. Here my my degrees are the same, so take the leading coefficients, 8 over 2. And finally, coefficients, the degrees are the same between the third fraction, so I'm just left with 16 over 6. Add those together, 2 plus 4 plus 8 thirds, which is 26 over 3. And the reminder is treat n as a constant, which means that you do want to pull this in front, and that will help you isolate and identify the appropriate rules that you want to use for the formulas.